Good day, we are Group 11 under Sir Adrian Oblena of GED104, Science, Technology, and Society. We are here to present our infographic titled Sensor-Based Smart Bin with Waste Classification and Tracking. Let us begin with the first section of the infographic titled What the Technology is All About. A smart bin is essentially a modern garbage disposal unit enhanced with sensors and microcontrollers. These components allow the bin to detect when it is reaching the capacity and in some cases even assist in sorting waste into categories automatically. Platforms like Bingo, not Bingo, helps users recycle properly. Bingo is a clear operational framework that supports consumer awareness of whether waste is recyclable or non-recyclable. This learning system promotes resource recycling through an interactive architecture, enabling users to recycle ethically and with precision. In our proposal, we focus on developing a smart bin that can do more than detect fullness. It will segregate incoming waste into 5 main categories: biodegradable, non-biodegradable, recyclable, non-recyclable, and hazardous. This makes the process more accurate and informative even without constant.
Now moving to the next section of our infographic. Smart bins were developed as a response to everyday problems such as overflowing garbage, delayed waste collection, and ineffective recycling practices, particularly in urban areas. The concept gained attention in the early 2010 when countries like Singapore and South Korea began their testing solar-powered smart bins equipped with sensors. These bins could detect when they were full and send real-time notifications to cleaning personnel. Some even use compactors to compress trash, allowing them to hold more waste and reduce the frequency of collection. As technology advanced, newer models were created that could automatically identify recyclable materials using AI functions. Some smart bins began offering visual instructions or feedback to help users sort their waste correctly. In areas where these systems were piloted, the results were promising. Waste collection became more efficient, bins less likely to overflow, and public awareness of proper disposal significantly improved. These developments paved the way for the smart bin technologies we know today, showing how innovative tools can support cleaner and more sustainable waste management practices.
Now, let us proceed to the next section, titled How the Technology Works. As shown on the infographic, a smart bin functions through a combination of sensors, mechanical components, and a microcontroller. The sensors are responsible for monitoring the fill level inside the bin. When a certain level is reached, the system may activate a light trigger, a signal, or notify users that the bin needs to be emptied. Some smart bins are also equipped with motorized blobs or dividers which allow the system to direct waste into separate compartments, such as recyclable, biodegradable, or hazardous, depending on sensor input. These components are managed by microcontroller, which is programmed to interpret sensor data and perform appropriate action automatically. This structure improves collection efficiency, promotes proper sorting at the source, and supports better waste management decisions by providing a clear view of waste composition over time. Let us now move on to the section titled How It is Helping the Society. Smart bins are more than just technological tools, they offer a practical and sustainable approach to modern waste management. These systems assist both individuals and institutions by encouraging accurate waste segregation and making the process more accessible and efficient. By continuously monitoring and separating waste types, smart bins help reduce the number of unrecyclable materials sent to the landfills. This limit the emission of greenhouse gases and decrease the number of plastic and metals that would otherwise pollute the environment. They also support business, schools, and communities in strengthening their recycling efforts, making waste handling not only more responsible but also more organized. In short, smart bins promote environmental awareness, accountability, and a more ethical approach to disposal practices, offering benefits that extend to both society and the planet.
To close our presentation, I will now discuss the final section, possible challenges and implications from technology use. Despite the benefits offered by smart waste technology, it is important to acknowledge that there are also challenges and considerations involved in its use. The issue of overproduced waste remains a global concern, one that requires creative, technology-driven solutions to ensure the optimal use of resources while supporting sustainable development goals. Traditional waste management systems often struggle to address the rising volume and complexity of waste, especially when environmental impacts are considered. In this context, artificial intelligence or AI becomes a defining technology. Its potential lies in its ability to assist in waste collection, sorting, recycling, and monitoring. However, the integration of AI also comes with key requirements, such as improving the quality of data, ensuring solid privacy policies, maintaining economic viability, and enforcing ethical governance. Furthermore, as this technology evolves, we foresee possible integrations with the Internet of Things, advanced machine learning methods, and even collaborative frameworks between engineers, community, and policymakers. This challenge must be carefully considered as we aim to create smart systems that are not only effective but also responsible, secure, and socially inclusive.
Lastly, we would like to acknowledge the references used to support this proposal. All sources cited in this project are listed at the bottom right of the infographic, including published journals, review articles, and official websites related to smart bin technologies and sustainable waste management. Thank you, and once again, this is Group 11 of GED104, Science, Technology, and Society.